Number 105, describe the molecular structure around the indicated atom or atoms, and then we want to find the molecular structure for each of the carbon atoms in allene, which is H2CCCH2. Okay, so whenever we want to find a molecular structure, the first things first is that just take a couple of seconds, and you can always get the molecular structure from drawing a Lewis structure. Now, a Lewis structure is basically going to unlock a lot of answers. Molecular structure, draw a Lewis structure. If you want to find out hybridization, if you want to find out, single, double bonds, triple bonds, Lewis structure will get you there. So the first thing we're going to do is just take a few seconds and draw out what this compound actually looks like. Now, there's tons of videos on this channel just designated to drawing the Lewis structures. So if you do need more assistance, you can always go back there. This one will kind of be like a quick inversion. But what you can do is you can pause the video, see if you could draw allene, and then see if your answer matches mine. Now, when we're dealing with organic molecules that are just based off of carbon and hydrogen, right? Not the organic in the store. Organic chemistry is the study of carbon, basically. But for this, if they talk to you in terms of like not talk to you, but if they write out the compound, kind of like in this longhand fashion, the best thing to do is to draw the Lewis structure from the left to right. Now remember, hydrogen can never be in the middle. So these two hydrogens have to be bound to a carbon. So I have a carbon, and I know that there's two hydrogens on the left side. Now, does it really matter if you draw it as H and H, or maybe the H and the H, or if you want to make it like this? Doesn't matter to me. Maybe we'll be creative, and we'll draw it kind of like on a diagonal. So two hydrogens bound to a carbon, which is bound to another carbon, which is then bound to another carbon, and that carbon has the two hydrogens. So just like I put them kind of here, I'll put them like this. Okay, cool. So now, remember, hydrogens can only make one single bond. They never have lone pairs, and they just want to be singly bond, one line. So that's what I'm going to do. I'm going to draw one line, one, and one. Now we need to get the octet for the carbons. Keep in mind that carbon had 4 valence electrons. It used 2 to get those single bonds, so it has 2 left over. And we need 8 electrons, so 2, 4. If I put a single bond, that would be 6, and the double bond is 8. The same thing for this one, right? 2, 4, 6, and 8. And just check that middle one, but 2, 4, 6, 8, it's got the octet. So we have successfully drawn allene. How fun! But anyway, because now we have a Lewis structure, we can find the molecular structure, right? And they want the molecular structure for each carbon atom. So there's 3 carbons, right? There's C1, there's C2, and there's C3. Now try not to do more work than you have to, right? Try to pick out similarities. Now the end carbons number 1 and 3, they both have the 2 hydrogens and the double bond, right? This carbon has the 2 hydrogens and a double bond. This carbon has the 2 hydrogens and the double bond. So these 2 carbons, whatever the shape of those are, they're going to be the same. So you only have to do one of them, and then you got both answers. Now this is where this lovely little chart comes in. Now when I was when I was learning this material, my teachers and professors, they said, good luck, you have to memorize it. Maybe your teachers or professors, they're kinder than what mine were. But you might need to memorize all of these, or your teacher might give them to you on a test or quiz. But if you do need to memorize them, just use flashcards, do whatever you got to do to just make sure that you know the difference between all of your molecular structures. Now, the big thing about this is that the first thing you always want to find out is the total number of atoms and the lone pairs around the atom that you're talking about. And since these are the same, it doesn't matter which one. So let's do carbon number 1. How many atoms and lone pairs is around this carbon? Well, there's the hydrogen. That's directly bound to the carbon. There's the other hydrogen. That's directly bound to the carbon. And then we have a carbon that's directly bound. Keep in mind, I don't care about these 3 atoms, the C or the 2 H's, because they're not directly bound to the carbon. So in this case, it has 3 atoms. And how many lone pairs? Were there any dots here? I don't see any dots, right? I don't see any lone pairs. So 0 lone pairs. Now, in order to find out what total number you're on, right? Oh, that was a crazy line. 2 through 6, all you have to do is just add up the atoms and the lone pairs. So 3 plus 0 is 4. Just kidding. 3 plus 0 is 3. So we know that we're going to be over here. But there's 2 options. These could either be in a trigonal planar format or a bent format. But we know that that atom has 0 lone pairs, so you just match up where they meet. In this case, both of those carbons, carbon 1 and carbon 3, are going to be trigonal planar. Which basically means that the angles around that atom, so in this case carbon, are going to be 120 degrees, kind of like a circle, right? If you split up a circle or a pizza pie in 3, you get 120 angles on both sides. So that's basically just what's telling you here. Whee! 120. And then the same thing goes for this one, right? And the way that I drew it, it does show that they are roughly about 120. Okay, so now let's do the carbon in the middle. Well, we got to find out what bracket we're in, number of atoms and lone pairs. So maybe I will just get rid of these just to make sure. But if we're talking about this carbon, now we only care about the atoms that are bound to it. So there's 1 carbon on the left side, and there's 1 carbon on the right side. These hydrogens don't matter because they're not directly bound to the carbon. So you got 2 atoms. And how many lone pairs? Once again, I don't see those dots, so 0 lone pairs. Find out what number you're at by adding them up. 2 plus 0 is 2. Whoop. So we know now we're up here. And for a tutor, you only got one answer, and that's linear. Which means that those bond angles, and it kind of looks like a line, right? They're 180 degrees. That's what a linear molecular geometry is. Straight line. And that is the answer. So we got trigonal planar for carbons 1 and 3 and linear for carbon number 2. And box them off. We are done. And I'm looking back at this and I have to give myself a pat on the back. Sometimes you just amaze yourself, right? Sometimes you look back and you say, wow, that's beautiful. But I might be a little weird. But hey, weirdness is different and being different is cool. All right? So always be you. And yeah, thanks for tuning in. I hope this helped. Let me know in the comments. Keep learning. Always keep learning. Keep studying hard. You guys got this, and I'll be here every step of the way. I will talk to you in later lessons. Okie dokie. Bye-bye.